find x and y. We have here a triangle, it happens to be a 30, 60, 90 triangle, and we'd like to try and solve for a couple of the leg lengths. We know the hypotenuse has length 50. We don't know how long x is, and we don't know how long y is. We could observe, of course, that these side lengths are going to have to be smaller than 50. Even if the picture wasn't drawn to scale, we know that the hypotenuse of a triangle is always longer than either of the two sides. So we know a little bit of information about x and y. They're smaller than 50. That's all we really know, aside from these angle lengths. And those angle lengths, those angle sizes are all that we need because we know a reference triangle for a 30, 60, 90. All right, we have this triangle here with length 1 and root 2, and 2 and root 3 as side lengths. And if we know one 30, 60, 90 triangle, if we know all the lengths of that one, we can go ahead and look at any pair of lengths here, look at their ratio, look at the corresponding pair of lengths here, look at that ratio, and those two ratios are equal. So say if we wanted to solve for y, I could look at the ratio of y divided by 50, and I could look at the corresponding ratio of our reference triangle, 1 divided by 2, and those two ratios are equal since we have similar triangles. So now solving for y is relatively simple. I multiply both sides by 50. I get 50 over 2 equals y. If you wanted to, you could go ahead and reduce this fraction a bit and see that y equals 25. So there's what our y value is. We can do a similar thing to solve for x. We have more freedom now. We could look at the ratio of x over y if we wanted to. We could look at the ratio x over 50 if we wanted to. We could even go ahead and use the Pythagorean theorem. After all, I know that 50 squared is equal to y squared plus x squared. And I know that y squared now is 25. So I could go ahead and take 25 squared. Of course, to use the Pythagorean theorem, I'm going to have to multiply out 50 squared and 25 squared and subtract 25 squared from both sides and find a square root of that. And, we could do that. But I think the easiest way is just to go ahead and use this reference triangle and look at a ratio again. So why don't we look at ratio? Let me dig out a different color. Why don't we look at, we used 50 before. We know what y is. Why don't we use y? Let's look at the ratio x divided by y. All right, so x divided by y is 25. In our reference triangle, this will be the ratio root 3 divided by 1. Those two ratios are equal. So we solve for x, multiply both sides by 25, and we get x equals root 3 times 25. And there is our solution. If we would have looked at a different ratio, we would have come up with the same thing. If we would have looked at x over 50, and the corresponding ratio here, root 3 over 2, we multiply both sides by 50. 50 divided by 2, that's 25. So once again, we get x equals 25 root 3. So we get the same thing that way. If you would, if you use this Pythagorean theorem way and reduce your final answer or simplify it a bit, you'd get the same answer as well. So any way that we approach this, we're going to get the same thing. I really like this, looking at a ratio here. It's quick, it's simple. These are 1 and 2 and root 3, pretty nice numbers to work with. So reference triangle, that's the way to go.